Hi, it's a pleasure to speak here again, my second time. This time I prepared a bit more detailed lecture about all the experiments, well, not all, but most of the important ones that Institute of Biomedical Problems of Russian Academy of Sciences was conducting during more than 50 years. So this IBMP, in short, is leading organization in space medicine and biology, and it was founded by Korolev, the father of cosmonautics. And since 60s, they've been studying the different effects of extreme space environment on human physiology and psychology. And the first isolation experiment that was conducted, it was Year in a Starship in 1967. It was designed to simulate the conditions of long duration spaceflight. 3 crew members, 3 men, were confined in a space 4.5 meters in diameter and 9 meters long. Their families were told that they are at Antarctic station, and so this experiment was a secret. These 3 men successfully did all the research experiments, but of course there was a downside of it, the psychological aspect, and also the immune system was decreasing, also after experiment finished, one of the crew members, he came out with stomach problems due to constant stress, since he was in between 2 fights all the time. So basically 2 crew members didn't get along, and so he was in the middle, and he suffered the most based on the results of the stress. But of course there was no fights, everything was decent, just internal miscommunication or misunderstanding of each other. Also in this year, crew members started to have increasing feeling of loneliness. So basically this experiment showed that everything is, humans capable of everything, but there need to be different countermeasures for preventing this kind of psychological effects, and also the what stress can cause to the physiology of human body. After this experiment, I'm not sure if it is, we have a book in English, but one of the crew members read this book, wrote this book. You can, find out in details how challenging this was. And also the love stories that happened between the crew, one of the crew members, and outside of the crew, the mission control specialist, the girl that was talking to them, and he fell in love with her voice. So when he came out, they actually got married. Yeah, something, good comes out from this. So after this experiment, IBMP had a series of different isolation experiments, and one of them called Sphinx. So it's a simulation of flight of international crews of International Space Station. And it was, the crew was different during several months, but there were 11 men and 1 female. And some people that are into this field of isolation experiments and history of IBMP, they know that there was a scandal between a Canadian woman, a crew member, and a Russian crew member. And honestly, still, I'm not sure which side to take, or what is the truth, because, different sides, they have their own truth. But it also showed that when you add gender diversity, then come out some risks and some challenges. So after that, after the Sphinx 99, IBMP had the revolutionary, it's still a record-breaking experiment, Mars 500. So 6 crew members, 6 men, spent 520 days in analog Martian station. It was also interesting how, first of all, how they were prepared for this long duration mission. They had to go almost through the same procedures as the real cosmonaut selection is going through. So they had the survival in winter time in Russian woods for crew dynamics and cooperation. They've been training and working together before the mission for 3 months. At the end, it was interesting that almost the last minute, the crew member from China was added into the crew, and he didn't speak Russian nor English. But after the isolation started, after like a month, scientists saw that they interact perfectly. They found their common language. Which one, we don't know. So it just showed that if you're in confined space and you have only 5 more people to be with you, you will find a way to communicate. And of course, Mars 500 was really tough experiment. Crew had different research projects on psychology, on physiology, and also the food studies. All the crew members lost a lot of weight. Of course, there was like huge differences in their psychological well-being. So they had mood changes. Also, communication with outside world was limited. So it increased the feeling of loneliness. Cognitive functions. So it was reported by the crew members that by the end of the isolation, they found it difficult to concentrate. So their concentration level was way better before the isolation, which is also interesting and gives us, a red flag about astronauts who would go to Mars, what they would encounter. And also there was a feeling of limited personal space. So this caused tension between crew members, but this all was sorted out after conversation. And finally, I think the most important was they came out from this mission that you have to talk and let it all out and let out your feelings, what do you want, and how you can navigate that. So all these psychological challenges that occurred, they were successfully navigated. And actually, this experiment showed that although human factor is the major unpredictable risks when we talk about long space flights, but it's still manageable, and we still can work on that. And here is the station where crew Mars 500 lived. So you can see here, it's a hangar that simulates extravehicular activity. It can be a Mars planet or it can be a moon. And below, it's 250 cubic meters module where we have the storage systems, fridges, and gym, showers. Then we go to the 150 module, and it's crew quarters, kitchen, living room. Then we have here is the module 100, which is medical module, where we have all the experiments and different procedures. And we have this, the smallest module is 50 cubic meters. Usually it simulates cargo ship or the landing ship. And most of the time of simulation, it is closed. So like once a month or once in 3 months, cargo ships docks to the main station. Then we open this module and we can get the food and anything else that it was sent to us. So after Mars 500, IBMP started this series of experiments together with NASA Research, Human Research Program. And it's Scientific International Research in Unique Terrestrial Station. So first experiment was in 2017. It lasted only 2 weeks. It was with cosmonaut Anna Kikina that just recently had her first flight to ISS on Crew Dragon in October. And the second experiment was in 2019, and it lasted 4 months. In this experiment, I was a crew member. After that, we had 8 months experiment, and we are planning for 1 year experiment that should start in November this year. So about Sirius and my perception of this experiment, as you can see, the inside of the station looks like a sauna. And this is due to the fact that this station is fully hermetic with its own atmosphere, with its own pressure. So any material that would gas out gases that would be harmful for humans shouldn't be there. Therefore, the designers and scientists decided to have a birch tree on the walls. And back then, it was in 2010, they thought that also it will affect positively our psychological state. But we cannot take wood to this real space, so we have to figure out which materials we can use, and also the color, the structure, everything, how it would affect our well-being, because every day you live in this environment and you have nothing else new to see. So you have a sensory deprivation, which also can affect you negatively. You can start having depression, and mood swings. So the more colors, the more different textures or something that can change, the better. But also here you should be cautious how this changes or colors can affect, again, the crew. It might irritate or might cause the aggression. So it's really interesting field of studies, and I'm hoping to see that someone would come out with the best scenario. So we had EVA mixed with virtual reality because the hangar is quite small, so you cannot really go and explore the planet, like on the station, for example, that Mars Society has at Mars Desert Research Station. We have also mission support because one of the not realistic scenarios that we have in this mission is that all the life support systems, everything controlled from outside. So the crew actually cannot do anything. It can just monitor what's happening, the level of CO2, of oxygen, temperature, humidity. But if something breaks, only the crew outside, the crew on duty of engineers and doctors can help and figure out what's happening. So here's the mission support room on the left, and inside we have more than 80 cameras. It's, of course, they're not in the shower, not in the personal crew quarters, but all the rest is covered with cameras. And they're so precise that actually when we've been writing something, scientists could see what we are writing. But there was no recording of the voice, so they couldn't hear us. And actually, after even a few days, you start to forget that you've been watched all the time. And at the mission support only allowed the team that is on duty. So we have changing of the teams every 24 hours, and it consists of 2 engineers and 1 doctor and 1 lab assistant. And when we had the 8 months isolation experiment after this mission, I was on duty also. So I was an engineer and was monitoring the systems all the time. So even at night when the crew is asleep, there is 2 people who watch the monitor and make sure that everything is safe. Because as you can see, there is a lot of wood, so the danger of fire is really high. So what we've been doing there for 4 months, of course, number one, I think key to success of the isolation mission is not to be bored. In our case, we had, I think, too much work. So we had more than 80 experiments. All these experiments were on us. So basically we were the lab rats. It's most of them, it's psychological experiments and experiments on physiology. So every week, or every week almost, we had to give the blood, urine samples, samples of your number 2, the saliva samples, even the samples of our hair. And I was joking that what would be next, samples of our tears and sweat. Yes, scientists were really hungry for valuable data that they can get from the samples. And so basically they've been studying how the sleep deprivation, sensory deprivation, stress affects different parts of our body and also of our psychological state. And we learned how to do the ultrasound, which was quite interesting because basically we couldn't figure out, all the organs look the same, blurry something. But at the end, we finally managed to do that. So all of these experiments, they were actually really testing you too, because you have to not only live in confined space with 5 crew members who are your family, your colleagues and everything, with limited diversity of food, of clothes, of colors, of smells, basically of everything. But also there is a lot of procedures and tests on you which are not pleasant. So we also have the experiment how the level of pain perception changes. Of course, we were not tortured, but still you undergo through this, not really comfortable and pleasing procedures. And I think it's important in these moments to have the crew that has really high motivation, and this motivation should be based not on the money or fame. It should be based on what you bring to the space community and to science, that you are part of this bigger picture. It can be like really the smallest part that you're bringing through this experiment, but still that you bring something useful. And through this research, we are paving the way to the space exploration. And I found it that the crew members who had this altruistic, I guess, motivation, they managed to cope with all the limitations, with all the uncomfortable pain and other procedures the best. So they coped with that the best. And just, my remark in terms of how we should do the crew selection for real Mars missions. And by the way, so we are still open for a year isolation experiment, and IBMP is still looking for the best candidates to participate in that. So if someone is interested, write me. I will be happy to connect you with IBMP. All right, so we talked about the isolation studies, but then we have also other factors of extreme factors of space, which is microgravity. And of course, we have different scenarios here how to kind of simulate the microgravity. We cannot do it 100%, but still the dry immersion model is one of the best so far to simulate the negative effects of microgravity. So here you can see the pool covered with a thin waterproof cloth, and water inside is controlled. So which temperature the test subject wants, he can put it there. And the longest experiment that was, it's 56 days. It was in Soviet times. Since then, of course, we didn't do such a long experiment. Longest so far in modern days is 21 days. And how the whole story started. So it started with the flight of Soyuz 9 in 1970s. And for more than 2 weeks, 2 cosmonauts spent in a really tiny spaceship, and they didn't move much. So when they came back to Earth, they were so weak, they had such a increased muscle atrophy, they couldn't get out from the spaceship by themselves. They also had the heart problems. And this situation showed to the scientists that they have to do something. They need to find the countermeasures for microgravity. And to find this, they need to create this model that would simulate the microgravity. So in this model, this is the modern days. The first models were actually wet dry immersion. So test subjects were inside of the water all the time, which caused severe problems with skin. And after that, they came out to the better version of dry immersion. So what does it simulate? It simulates the supportlessness. So basically the same what we have on ISS. Then limitation in motor activity and hydrostatic compression of surface tissues and blood vessels. I was talking to cosmonauts, and we've been comparing the feeling that I was in a dry immersion and they were on ISS. And it's interesting that so many features were the same, which just proves again that this model is working. And especially we need this because we cannot send many people to space. We cannot send different equipment. Also, the new research been born every year about how we can mitigate the microgravity. So it's great option here on Earth to simulate that and to work towards the countermeasures. So since 70s, we had dry immersion experiments, but all this time they were only with male test subject. And only in 2020, we did the dry immersion with 6 female test subjects. And I was one of them. So here you can see one of the our research that's been going on there. So it's the study of influence of dry immersion on the characteristics of our food. We were, of course, not bored because, again, all the time while you're laying down in this bath, there are scientists coming, taking different measures. Also, you cannot do anything by yourself because for everything you need to call for the lab assistant, basically clean your teeth, eat, go to the toilet, and all these procedures limited you even more. So if you are talking about the psychological effect, first, we're in isolation. So we're limited in space, in communication and other things. But here in Bath, you're limited even in walking or doing anything that you want. And it's really interesting how this affects your well-being and how your body also reacts to this extreme new environment. And for me was the most interesting how my signals that I was sending to my body, they were not understood by my body in this new environment. And I was really amazed. I was like, oh my God, my body is not listening to me. What can I do? Because it never happened before. That's one of the factors that also astronauts would have when we are talking about real space flights. So here you can see that we did like simple tests as Lushare tests, where you choose from the most pleasant color to the least pleasant color. Also, there have been a VR system to help you take off some stress. And in general, all the crew members, or not crew members, test subjects, they did great. So the most interesting thing that was different from male test subject and female test subject is that male test subjects, they had the back pain. It started after day 1. This is due to that your spine stretched, and so the muscles and nerves, they're affected by this. So for example, after my first day, I became higher 1.5 meters. Also, your body loses a lot of liquid because of the pressure of water on your lower part of the body. So I lost 2.5 liters. And also it might, scare some test subject, like what's happening, why I want to all the time pee, what's going on, is it normal? And in this case, there are psychologists that come to you, and also the doctors who talk to you and keep you safe and calm. So it's really important to have this communication. Apart from the back pain, other issues that occurred, it was gas formation, because again, water has this pressure on your lower part of your body all the time. So that's how your body reacts. And so with female experiment, we had only it for 3 days, because it was first time with women and they didn't know what to expect. But these 3 days is not the best, because exactly in these 3 days, your body adapts to new environment. So you're feeling not the best. And on the day 3, finally, you start feeling great in this bath, but they take you out. So you have to readapt to Earth gravity. And again, you don't feel good. So next Immersion that was held in 2022 was way better. It was for 5 days, and the same test subjects that were with me on the first one, they said that 5 days is way better, because you start to enjoy actually floating in this bath. So during this immersion, different scientists tested countermeasures, and one of them can be the electrical stimulation of your muscles of your legs. And in general, it showed that yes, men and women has differences, but women are actually way more responsible, and because I think they really felt this weight on them that it's for the first time, and we want to represent the whole gender professionally. So the test subjects really did great job. And I'm really curious to see the differences in the longer dry immersion, which will be 21 days with female test subjects. Apart from that, also IBMP has the short radius centrifuge. So this to conduct the research on the problem of artificial gravity. Of course, the best scenario for mitigating the microgravity effect is to creating this huge station that rotates, but I think it's not realistic in the close future, and that's why they offer to have this short radius centrifuge on board of the space station that travels to Mars, and to use it for a couple of hours every day, which will help astronauts stay healthy, and at the same time they still will be in the microgravity, so they would be adjusted to both conditions, and they would be way more prepared for landing to Mars and starting working straight away there. And also it's important to understand which axis to use in this centrifuge. So the best one is longitudinal axis, so from head to your toe, and this helps a lot also with blood pressure and in general the cardiovascular system, and mitigates all these negative effects that usually astronauts have, although they train a lot every day on ISS. And another really interesting experiment that just recently IBMP started, it was a few years ago, called ARFA. Basically, so we know that on Mars, the magnetic field is way lower than on Earth. And there have been studies on mice, on different other animals, when they're living in hypermagnetic environment, how it affects their their physiology. So apparently it affects cognitive functions, and also it affects the fertility. And just imagine if we don't study this, what risks might occur when we have astronauts living on Mars for several years. So IBMP started this experiment. So it's basically like a Faraday cage. And here we have only 1,000 times less magnetic field than on Earth. They had this interesting scenario. So the test subject first spent 24 hours in the decreased magnetic field, and they've been watching how it can affect his cognitive operation functions, visual. After that, he came to spend another 24 hours, but he didn't know that there is actually no, they didn't change any magnetic field. He was just in the Earth magnetic field. So basically placebo version. So they also wanted to study how this affects your psychological state and how you, your perception of the experiment. But it's still not much, even 24 hours. So as a result, scientists didn't see any difference. Of course, it's tricky to, ask volunteers to spend a year or even like 6 months in hypermagnetic field, knowing that it might have a huge risk on your health in general. So it's interesting how we can mitigate that and how we can study this more if we are using real people. Okay, so yeah, here you can see the other pictures. Of course, no gadgets allowed into the cage, so that's why you just read the old-fashioned book or play chess. And yeah, I think I was really fast, but I'm open to the questions because through questions I can talk more what people are interested in.
Yeah, thank you so much, Anastasia. That was perfect. Actually, you touched on a lot of really interesting points. So hopefully we can have a bit of a discussion now. So if anyone has questions, please put them in the chat. And then we did get some questions while you were presenting. So I'll just start off with those. One person was asking about your experience during simulated mission control. So did you find that it was very immersive in the sense that you have moments when you forget that you're in a simulation?
Does he mean like when I was in serious project in the isolation experiment, right? Or when I was outside of and I was in mission control?
I'd be curious to hear both.
Okay. Yeah, so if we're talking being inside, being a crew member, I think it's really important, the design of the station, the environment, to make you feel like it's not simulation. We were aware that it's experiment, and yes, we didn't feel that we're in real space. Also because, as I said, there is a wooden walls, so we're not gonna have it there. But we were not playing the roles, we were actually working, and we took it really professional. So as we would take it in a real space flight, and especially the crew commander that was with us, he's a real cosmonaut that flew to ISS in 2014. So his approach and work really put us together, and yeah, united, and also made us, I guess, more professional. And if I talk about the mission support that was a few years after, I think it's important to have in mission support people who also went through the isolation or to this kind of experiment, because then they understand way better what's happening with the crew. So from the cameras, it's so often people don't understand what crew is doing. Like we send them a message, okay, you need to do that. And crew starts to do something else. Or has different questions, and often I was this bridge between people who, the scientists and the crew, because I was like, no, you didn't understand, they want this. And so basically, in understanding both sides, but that's because I was inside there and I know that perception changes. So it's important, yeah, to have also in mission support someone with this kind of experience.
Yeah, that's a really good point. I imagine it would be the same also if you have someone involved in the mission who has done another mission before. Probably that experience, helps deal with the issues that arise. Another question, someone would like to know a bit more about the psychological experiments that you do during the mission. I think you mentioned, it has an effect on the cognitive abilities, etc. So how are these kinds of things assessed?
Yeah, so we had a lot of surveys from both from NASA and from Russian scientists. So basically the first thing when you wake up, you fill in the psychological survey. The last thing you go to bed, before you go to bed, again, survey. And the questions that can be different, like, do you want to commit suicide? Do you hate your crew members? How do you feel, like, and etc. There were many other tests, for example, on perception of time. So when one of the crew members has the timer, but the other one doesn't have any watch with him or her and cannot count, and you just ask them, tell me, when do you think 1 minute would pass? So it was interesting that they, different crew members had like minute, only 20 seconds. The other ones had it for 2 minutes. And this perception of time stayed almost the same during 4 months. We have different tests on the level of cortisol, so basically stress tests. We've been doing the mathematical equations together with disturbing sound. We've been watching, this was an experiment by a German university. So they've been showing us like 30 pictures of violence and real violence, like blood or disturbing images, vomiting, and nothing pleasant. And the other 30 pictures of something really good. And you have to choose how you see it, positively, negatively, and how it affects you, how deeply it affects you. And they wanted to see if our also feeling towards this changes with this 4 months. And of course it changed, because you've seen already this picture, so you get used to them. And I think maybe they should change the approach. Maybe they should change the pictures. Like, it's still violent and bad, but it just all the time new pictures. Then they can see, I think, the real reaction of our feelings, like, because I think they wanted to see if we became more indifferent in this sensory deprivation environment. So it's interesting, yeah. And many psychological surveys also have minuses, because also you see the same questions every day. So then automatically you just fill it in, and not always it represents your real feelings. And how to navigate that, I know, poor psychologist, poor scientist who wants to get the real information. It's really hard to actually come up with the experiment that can, can see the real issues of each crew members. Yeah, so.
No, that's a really interesting point, actually. The repetition of the surveys. I think there's a lot of research to be done also into how we administer these kinds of psychological measures. So we had another question about the hypomagnetic research. Is this something that's still ongoing, and how long have subjects been exposed to these conditions?
So for now, I think they did several runs of this experiment. I'm not sure that now it's going on, but this for sure will continue with this experiment. They had the exposure for 24 hours for, with the breaks in between, like, and then again 24 hours. So basically not much, just few days. And as I said, if you know that, for example, mice got this result, that they have problems with cognition, and I don't know which person would come and say, hey, I don't care if I become dumb and I can't do anything, let's do this experiment. So it will be hard to test it also on people.
Mm-hmm. Yeah, I think the magnetism thing is really interesting too, because if you think about, I mean, Earth's magnetic field also protects us from cosmic radiation. And so when you're on Mars or the moon, it's not just, the effect of the magnetic field or the lower magnetic field on your body and your cognition, but also the radiation effect. And obviously that's something that's very hard to study as well, because you're not going to just expose people to radiation to see how they cope. So I think it'll be interesting to see how these things play out once we actually start going into space. Someone had a follow-up on your previous, I think, related to psychological surveys, but maybe also in general. Is there anything that you think was under-tested or that was missed during the missions? Do you see any gaps as the top priority?
Yeah. As I said already, that the repetition, that's one of the issues, and also crew started to get sick of it, of the same question. So they might get irritated or, on purpose, like copy the same answers from the previous months, and how to also control this, which is hard. I think also important the psychological support during isolation. When you're inside, all the small problems that happen inside, for you, they seem huge. For the mission support, they have their own life and many other things to do, so they don't treat it as such a important and big problem. And that's how many conflicts arise between the mission support and the crew, because just they don't understand each other. Or like, we request for something and it was ignored. We thought it was ignored, but they've been just working on it, but just too slow. And, that's how this whole thing starts. And yeah, so it's important to have, I think, really good psychological support. Like it can be a psychologist assigned to the crew that can talk to the crew through emails or well, it's hard to do even the phone calls, because if you are talking about the moon simulation, then there is not much time delay. But if you are talking about Mars, then it will be hard. So to really think of other ways helping the crew, feeling safe, and by feeling safe also, it's important that I mean, even astronauts and cosmonauts has this issue. They cannot be honest during their space flight, because then it can affect their career. So, if you really complain about something or tell that, hey, I feel like, I don't know, sad today or something like that. No, they always have to keep, this kind of poker face. And if we're talking about Mars and, really long space flight, just imagine when you cannot vent or talk to someone outside of your crew, because you also don't have to do this venting on your crew. It will cause even more drama. So you need to have this kind of psychological support, and maybe AI or robotic system is a good scenario in this case, because your conversation will just stay between you and this system, and then nobody would know, but at least you talk to someone. So at compromise.
Yeah, I think it's really interesting that you brought up this idea of feeling safe to share your feelings. I know a lot of people who struggle with mental health, especially in the space industry, feel like they can't talk about it, or even go see a therapist, because then it's on your record and that might somehow disqualify you from future space missions. I had a lot of talks with my classmates about this, and they're like, yeah, maybe I could see a therapist, but I probably won't. So I think this is also, it should be kind of a cultural shift in the space industry, because when we talk about inclusive space exploration, it does go beyond just, nationality and race. It's also people of different abilities. So no, I'm really glad you brought that point up. It's not very often talked about. I did want to ask you also in terms of the crew dynamics. You mentioned early in your presentation, there were some issues when gender was introduced as kind of an additional variable. And I know there's been a lot of missions where it's just been male participants. So I'm curious about the all-female missions. Have there been any interesting outcomes? I know there's only been a few so far, but I'm curious to hear your thoughts about that.
Yeah, actually, just recently I published article, although it's in Russian, in Forbes Women Russia, about this issue of a psychological aspect of all female crews or mixed, and that, before they had this stereotype that if we have a woman on board, then for sure there'll be drama, she would distract us from work and the flirting and all this. So with the Sphinx experiment, since it was in '99, and I don't know, I heard two sides of the story, so I still don't know what make out of it. I think it also was the misunderstanding in cultural way, because the crew member, she was from Canada, and Russian man is from Russia, so we have way different cultures, and maybe they read the signs of each other differently. So after the Mars 500, IBMP had all female crew isolation experiment, but only for 10 days. Was 6 crew members, all the employees of IBMP, and it was a good experiment because it showed that there was no fights, no drama, because another stereotype is like, oh, if you put only girls inside of one house, then there would be like a snake cage, serpentarium, so no, it didn't happen. Was all good. And I remember the girls, they were complaining to me that at the press conference after this, most of the questions were about, oh, how did you survive without the makeup? Oh, how could you be there without a shower? And all these questions. So we need to educate the public and audience, and I think recently it's been changing the whole picture of it. And so with the series, it was first time in IBMP history when we had an equal amount of men and women, and they also were curious how this would work, and it worked good. So we already had 3 experiments, and really long duration ones. So I think the best representation, of course, of us humans is when we have the both genders in the on Mars and anywhere else. And also it's due to the fact that we are different, but we can when we are together, we add the best. So even in physiology, even the microgravity affects differently men and women. So I think it's really important to have both.
Mm-hmm. Yeah, and I saw an interesting comment in the chat that there wasn't this concern when it was all male crews, but it seems to be a huge discussion topic. I will say though, because my organization, we're organizing an all-female analog mission in Jordan. And one of the reasons we're doing that is because we want to research women's health as well, because women are very underrepresented in the space industry, in analog missions, and women who have been to space. And so there's really a lot that we need to cover before we can, maybe start talking about sending all female crews actually to space, and actually researching how it impacts us. Yeah, I think there was another question in the chat. So someone's wondering, what's the path that a master's student would have to take to do similar research in terms of electives like biology or psychology?
So if this person wants to be in the crew or as a scientist outside of the crew and actually, organizing these experiments. It depends which side he or she wants to take. But if you are talking of crew member, no, you just have to have either engineering degree or science degree or medical degree, and just be involved in space somehow, be healthy. By the way, the crew selection, the health selection for a serious project was as rigorous as for the cosmonaut selection, and it was crazy. Like I never did so many tests, and I don't know, I think they saw every part of my body. Because they didn't want to stop the isolation if something happens to you. And actually, with 8 months isolation experiment, we had this issue. So one of the crew members, unfortunately, after 1 month in isolation, while during the exercise, there was accident and she broke her arm. So they've been thinking what to do, either stop the isolation or continue, but without her. So they decided to choose the second option. And so the crew dynamics were different because it's now, instead of 6 people, it was 5. So it's also interesting.
Yeah, definitely. I think one of the most important parts is, having contingency plans for when stuff like this happens. I think you also mentioned the idea of kind of the motivation for wanting to do an analog mission. So having this kind of altruistic motivation, which drives you to actually complete the mission. And I was curious, how is this actually assessed during the analog crew selection?
So we've been talking to different psychologists and did different tests, but it's hard because when you go inside and the simulation starts, people change, and you might not even realize yourself that you would be different in these conditions. So for me, it was also interesting how we can which methods we can use during the crew selection, because I was also part of crew selection for 8 months mission. And yeah, it was hard to understand how this person behaves with you. Of course, they all come and talk to you, you're like official, and they wouldn't tell you everything. So how to test that? And yeah, so that's interesting question for psychologists.
Yeah, fair enough. I think, like you said, it's one of the biggest things is like when people are under stress and there are all these environmental factors, it does, of course, influence how you're acting as opposed to, during an interview or something before the mission. So that's really interesting to think about. We have another question. If you had a chance, would you go to space? Would you go to the ISS or the moon or Mars?
Of course. Yes.
I think that's
I think most of people here would do that, right?
I would go to the moon, but I wouldn't go to Mars, to be honest. Because I would want to come back to Earth. I would still want to see the Earth as well.
Yeah, I mean, that's why we need to prepare for Mars so good. So, astronauts would go back to Earth. It's really important to have this hope that you can go back. And it will help you to just work and live on Mars better and productive, rather than when you think, oh, I would never go back, I'm doomed here. So that's not the best approach.
No, definitely. That seems to be the usual narrative that like it's a one-way ticket, which I find very unappealing personally. I see Martina, you're here, you unmuted. Did you want to ask something?
Yeah, I'm curious about the test that you did in submersion in the water baths. How did it feel physically and psychologically?
It felt uncomfortable, of course. I mean, first few hours is great. You're floating in this bath, and actually they've been using this bath for healing different diseases, like dealing with your with the stress and muscles, or just in general, when you're stressed out, you just lay down in this bath, turn off the lights. You know, it's like floating. But when you're there for more than 5 hours, you start to feel the difference. So I think for me, most uncomfortable thing was to actually, sorry for being honest, to pee. It's just because your body doesn't understand how to do it vertically and without any support. Not vertical, sorry, horizontally and without any support. So like you apply pressure, but nothing happens. So you send the signals like, hey, I wanna do this. But it took me some time to navigate that. And yeah, it's really, and also there is another problem, because they bring you the special kind of like pump, and it can leak, or you can, spill it somewhere, and there's people around you. I mean, they're not like watching 100%, but they're still like somewhere near to help you. So I think it's also psychological block, because first of all, someone is watching and you're not alone in this. But second, since you're a kid, you've been taught not to be under yourself, in bed or like in your clothes. And here you actually have to do that. And so I think it's also really interesting how to unblock this, psychological, I think, how you say it, things that you've been learning all the way. Yeah. So that was really, for me, a shocking thing. I thought like, hey, I did so many experiments, that will be interesting. But I didn't expect that my body would, bail on me. So, and we had also some of the test subjects, they had also motion sickness. So it's interesting how each test subject has its own challenges. But overall, yeah, it's just interesting feeling. It's really, and it's not easy. It's challenging. Yeah.
Do you think you will do the 21-day test?
Oh, I don't know. Yes,
how,
I was
how long
thinking
was
about
the
it.
previous one?
Oh, just 3 days.
Okay.
Yeah.
Wow, that's much longer.
Yes, well, we'll see. I don't know.
Yeah. Also, is there anything that surprised you about yourself during those different missions?
I think just physical things, like nothing psychological. Yeah.
Yeah, I imagine it's a lot of physical stress also to go through these all the different tests and people collecting samples and all the stuff that you mentioned. It doesn't sound very fun, but it is important research. So I understand the importance of the motivation behind it as well.
We also had, I forgot to mention, so we were having a biopsy so they took part of our muscle from our leg before that dry immersion and after, to see the difference. So basically we had like small surgery, and I mean, of course it's painful. So so you have to also be prepared for that. Yeah.
Wow. I mean, kudos to you, and thank you for being the test subject in this research.
Yeah.
That's hopefully gonna help humanity in our future endeavors.
I was joking, like I'm a big white lab rat. So
they do call them lab rats very often, so I get that thing. So we do have just like a minute left. I don't know, Marufa, if you had a question or.
I have a question. So space is something you were interested when you were little, like as a kid, or is it more recent, like 5 years ago or 7 years ago? When did it start?
I know I was interested since a kid because my dad was reading me science fiction books. So that's why? I said, Dad, why I didn't choose something more easy, you know? So, and now and then when I was choosing where to go for my university, it was, beginning of 2000, and back then space wasn't as in a good shape. So I didn't believe I have any chance, or, and it was, especially the Soviet Union collapsed and Russian space programs went a bit down. So everything was, not in the best shape. But after I finished my first degree in space journalism, then I was feeling that I'm not like living my life, like my purpose. This kind of feeling was always inside me, and I was like, no, I think I should try to follow my dream. We'll see what will happen. So I started to get involved in all the space projects as much as possible, and getting second degree, being more professional. So people would be like, would treat me not as just some blonde journalist, but more serious.
I think that's a really important point that, growing up, if you don't see the possibility to get into the space industry, it kind of pushes people out of this path, even if they're really interested. And so I think that's a very inspiring note to end on as well, that you didn't let that, be out of your reach just because of the circumstances. I think for a lot of people here, probably that applies as well. You have to follow what your heart is telling you is your passion. Even if there are, external circumstances, there's always a way, especially in the space industry, because we do need everyone in space.
Of course. And you're doing a great job. You're building a space in your country. So
we're trying, we're taking slow steps, but I think it's really important because, similarly, I didn't have these opportunities when I was growing up. So I didn't think it was possible. So I think it's also our responsibility for people like us that managed to get into the space industry to bring that back, because there are a lot of people who have these passions and dreams and just don't have the chance maybe, to go to another country to do it. So I think it's great to also form this community of people doing it in their own countries, and spaces should be all about collaboration in the end. So
yes.
So I think on that lovely note, I think we can wrap up the session. So thank you again, Anastasia, for this really, really great talk and discussion. Thank you everyone for your questions. I think, yes, you can send a clap emoji if you want. So I think I'll stop the recording.